Deep underground, a mine is not a place built for comfort. It is a world of narrow headings, wet rock, diesel heat, hydraulic pressure, dust, vibration, and noise that never fully disappears. Tires scrape over broken stone. Drill steel bites into the face. Engines echo through tunnels where daylight has no meaning. And above every worker, above every machine, above every decision, there is the weight of the rock. That weight is constant. For generations, underground mining has been a struggle between production and danger. The mine must advance, ore must move, ground must be supported, equipment must keep working. But the deeper the operation goes, the more unforgiving the environment becomes. In that kind of world, a machine is never just a machine. It can be the difference between a job done safely and a worker standing too close to unsupported ground. It can decide whether a shift keeps moving or stops underground. It can reduce exposure, or it can create new risk. It can be designed from a distance, or it can be designed by someone who understands what the mine is really asking for. That difference is the beginning of MacLean Engineering. The company did not start as a global name. It did not begin with a vast factory, a giant corporate parent, or a famous public brand. It began in Ontario in 1973 with Don MacLean, a mining engineer who had seen the underground world directly and believed that equipment should be shaped by the realities of the mine, not by the imagination of a showroom. From that belief came a Canadian manufacturer that would grow into one of the most important names in underground mining equipment. But this is not a simple story about a company getting bigger. It is a story about a hidden industrial battlefield, one that most people never see, where manufacturers compete in darkness, heat, dust, and pressure, where reputation is earned not through advertising, but through uptime, where a machine either survives the mine or the mine rejects it. MacLean Engineering rose because it understood something brutal and practical. Underground mining does not reward the loudest company. It rewards the company that understands the mine. To understand why MacLean mattered, you have to begin before the factory, before the product line, and before the international branches. You have to begin in mining towns. Don MacLean grew up around the mining camps of northern Quebec, in places such as East Malartic, Noranda, and Chibougamau. These were not towns where mining was a distant industry discussed in reports. Mining was the reason the towns existed. It shaped the roads, the schools, the paydays, the kitchen table conversations, and the way families understood risk. The mine was not just an employer, it was the center of gravity. In communities like these, children learned early that the underground world gave and took at the same time. It gave wages, skills, identity, and purpose. But it also demanded endurance. Workers went below the surface carrying lunch pails, lamps, tools, and a quiet awareness that the rock above them did not forgive carelessness. That background matters because MacLean's company would later be built around a very specific idea. Mining technology is never only about extracting ore. It is about whether people can return to the surface safely at the end of a shift. Don MacLean studied mining engineering. He worked underground. He saw the changes taking place in hard rock mines. For decades, many underground operations had depended heavily on rail-based systems, with equipment moving along fixed tracks. But the industry was changing. Rubber-tired mobile machines were becoming more important. They could move more freely. They could reach places rails could not. They promised more flexible production, but flexibility came with its own engineering problems. A machine built for the surface could not simply be forced into a tunnel and expected to succeed. Underground equipment had to be compact enough for tight headings, strong enough for brutal ground conditions, and reliable enough to work far from ideal maintenance environments. It had to handle water, dust, vibration, heat, steep ramps, and constant punishment. And most importantly, it had to be designed around the person operating it. That was where MacLean's thinking began to separate itself from ordinary manufacturing. Many companies begin with a product. MacLean Engineering began with a working condition. The company's early philosophy was not simply to build equipment. It was to look at the mine, listen to the problem, and build the machine that should have existed already. That sounds simple, but in heavy industry, It can be the difference between a company that survives and one that disappears. Because underground mining punishes arrogance. A vehicle may look powerful in a brochure. A design may look efficient on paper. A system may satisfy a spreadsheet. But none of that matters if a mechanic cannot reach a broken component underground. None of it matters if an operator is forced into unnecessary exposure. None of it matters if the machine cannot keep working through heat, dust, water, and abuse. MacLean's advantage was proximity. It came from understanding the mine not as an abstract customer, but as a physical place. That is why the company's beginning has become part of its identity. The story starts not in a massive industrial complex, but in an apple orchard barn in Thornbury, Ontario. A modest place, a practical place, a place where farm tractors could be modified, ideas could be tested, and problems could be turned into machines. There is something fitting about that origin. A company that would eventually serve mines across continents began with adaptation. It did not have the scale of the global giants. It did not have their catalogs or their capital. But it had something else, a narrow, practical understanding of underground work. And in mining, narrow problems can be extremely valuable. A mine is full of tasks that may look small from the outside, but are critical underground. Ground support, explosive charging, shotcrete transport, secondary reduction, utility work, maintenance support, moving people, tools, and materials through restricted spaces. Each problem demands equipment that is not just strong, but specific. This is where MacLean found its place. The company could not outsize the largest manufacturers, but it did not need to. A giant can dominate a market category. A specialist can dominate a problem. And MacLean's rise came from treating underground mining's difficult, unglamorous problems as serious engineering territory. One of the clearest examples was ground support. After rock is blasted and removed, the newly exposed ground has to be stabilized. Roof bolts and support systems are not secondary details. They are part of what stands between workers and one of the oldest dangers in mining, falls of ground. For much of mining history, this work placed miners close to unsupported rock. It was physically demanding, it was hazardous, and it had to be done well because every development heading depended on it. The challenge was not simply to make bolting faster. The challenge was to mechanize the process while reducing exposure, improving consistency, and allowing the mine to keep advancing. The MacLean scissor bolter became one of the company's defining machines because it addressed that problem directly. Its significance was not only that it installed bolts. Its significance was that it changed the relationship between the worker and the danger zone. By allowing ground support work to be carried out from a protected position, it helped shift underground mining away from older patterns of exposure and towards safer, more mechanized practice. That kind of machine rarely becomes famous outside the industry. It does not have the glamour of a sports car, the public visibility of an aircraft, or the mythology of a locomotive. It works in darkness, in tunnels most people will never enter, doing a job that only becomes visible when it fails. But inside mining, that kind of machine matters deeply. It changes the workday. It changes what a supervisor can plan. It changes the rhythm of development. It changes the level of risk a worker has to accept. And for families waiting above ground, even if they never know the model name, it changes something even more important. The chance that someone comes home safely. That is what MacLean was really selling, not just steel, not just hydraulics, not just underground vehicles. It was selling the possibility that safety and productivity did not have to be enemies. As mines became deeper and more complex, that idea became even more important. Depth changes everything. Heat increases. Ventilation becomes more difficult. Distances grow longer. Equipment has to travel farther, work harder, and survive in harsher conditions. A minor design flaw on the surface can become a serious problem underground. In that environment, details matter. The position of a hydraulic line, the protection around a cab, the visibility from the operator's seat, the way a service panel opens, the ability of a mechanic to reach a component at the end of a hard shift, the durability of a frame under constant stress, the confidence that replacement parts and support will be available when a machine is down. These details do not usually appear in business histories, but they are often where industrial reputation is made. MacLean built its name in those details. Its product lines expanded across the kinds of machines underground mines actually needed: bolters, for utility vehicles, shotcrete equipment, explosive charging equipment, secondary reduction machines and service vehicles. These were not glamorous machines, but they were essential ones. And essential machines create a different kind of loyalty. Mining customers are not buying romance. They are buying uptime. They are buying service. They are buying a manufacturer's willingness to answer when something breaks underground, and every lost hour costs money. So MacLean's growth was not only a story of engineering, it was a story of trust. That trust also gave the company a role in the communities where it built. In Collingwood and other Ontario locations, MacLean represented something increasingly rare in modern industry: advanced manufacturing rooted in a regional workforce, but connected to a global market. A machine built in Canada could end up working in Mexico, Peru, South Africa, Australia, or elsewhere. Behind that machine stood welders, machinists, engineers, assemblers, electricians, designers, service technicians, and support staff. Local skill became international capability. That is one of the overlooked powers of manufacturing. A factory does not only make products, it stores knowledge, it teaches trades. It preserves habits of precision. It gives younger workers a reason to learn how steel, hydraulics, electronics, software, and field service come together inside a real machine. It turns individual skill into institutional memory. Every vehicle that leaves a factory floor carries hundreds of decisions made by people most customers will never meet: how thick the protection should be, where the operator should sit, how the machine should be maintained, what can be repaired underground, what needs to be simplified, what must never fail. This is why the factory matters, not as a nostalgic symbol but as a living system of knowledge. MacLean's rise was built on that kind of practical intelligence. But the world it served did not stand still. The same mining industry that created the company's opportunity kept changing around it. Safety expectations increased. Global mining companies became more demanding. Larger competitors watched the market. Mines went deeper. Ventilation costs became more significant. Productivity pressure intensified. And the diesel-powered underground fleet, once a symbol of flexibility and modernization, began to reveal a serious weakness. Diesel had helped mines move beyond fixed rail systems. It gave underground operations mobility and power. But in a confined mine, diesel does not simply disappear into the air. It brings heat. It brings exhaust. It brings particulate matter. It adds to the ventilation burden. And ventilation underground is not a minor expense. It is one of the systems that makes mining possible. Air has to be moved through long networks of tunnels. It has to be managed, cooled, heated in some regions, and monitored. The deeper and hotter a mine becomes, the more serious the challenge becomes. Every diesel engine operating underground adds to that problem. So the question began to change. For decades, the industry had asked how underground machines could become more mobile, more powerful, and more productive. Now it was also asking how they could become cleaner, quieter, and easier to integrate into a mine with rising environmental and ventilation pressures. This was the next turning point. The future of underground mining would not be defined only by stronger machines. It would be shaped by cleaner machines, battery electric vehicles, data-rich systems, equipment that could reduce underground emissions and help mines rethink the cost of moving air. MacLean recognized the importance of that shift early enough for it to matter. In 2015, the company began serious product development work around battery electric mining vehicles. This was not simply a branding exercise. It was a response to a real underground problem. Electric equipment promised important advantages: less diesel particulate matter, less heat, less noise, and the possibility of reducing ventilation demand. But underground electrification is not as simple as replacing an engine with a battery. A mine is harder than a road. Battery systems have to endure vibration, moisture, heavy loads, steep grades, irregular operating cycles, charging limitations, and the economic pressure of production schedules. A battery electric machine cannot be treated like a delicate experiment. It has to earn trust in the same brutal environment as the diesel equipment it hopes to replace. This is where MacLean's history mattered. The company understood that the technology alone was not enough. The battery had to fit the duty cycle. The vehicle had to fit the mine. The charging system had to fit the operation. The machine had to be accepted by workers, mechanics, managers, and customers who could not afford failure underground. The electric mine would not arrive because someone built a beautiful prototype. It would arrive when a working mine trusted the machine enough to put it into production. For MacLean, electrification became another version of the same original idea. Start with the mine's problem, then build toward it. That is also what made the company's position against global giants more interesting. Large multinational equipment manufacturers had advantages MacLean could not ignore: scale, capital distribution, and broad product portfolios. But size can also create distance. Layers of management can slow decisions. Broad catalogs can make narrow underground. Problems seem less urgent. A specialist manufacturer can sometimes move faster because it is closer to the customer and less trapped by its own machinery. MacLean's advantage was not that it was bigger. It was that it could remain focused. It could look at underground mining not as one market among many, but as the core reality of the business. It could treat a ground support issue, a service challenge, or an electrification problem as central rather than peripheral. That focus became the thread connecting the company's chapters. First, the industry needed better mobile equipment for underground work. Then it needed safer and more productive ground support. Then it needed a broader support fleet. Then it needed cleaner, electric and more advanced machines that could work inside the mine of the future. At every stage, the question changed, and the company had to change with it. That is where many industrial firms fail. They do not always collapse because they are lazy or incompetent. Often, they decline because they keep solving the problem that made them successful long after the market has moved on. Their factories remain busy. Their people remain skilled. Their machines still work. But the customer has started asking a different question. MacLean's survival came from continuing to listen for that next question. Its expansion beyond its original Ontario base was part of the same process. A company serving global mining cannot remain only a local supplier. Mines operate across countries, climates, regulations, languages, and geological conditions. A customer in Mexico, South Africa, Peru, Australia, or Canada needs support that feels close enough to matter. Underground equipment is not a one-time transaction. It is a long relationship. Machines need commissioning. Operators need training. Parts need to arrive. Field technicians need to understand the conditions. Engineers need feedback from the mine. Problems discovered underground have to travel back into design. A factory may build the machine, but service protects the reputation. That is why MacLean's global footprint mattered. It was not only about selling more equipment. It was about proving that a Canadian manufacturer could support mining customers across continents while still preserving the specialized knowledge that made the company valuable in the first place. That balances. Difficult growth can stretch a company. It can complicate quality control. It can separate decision-makers from the field. It can make a specialist behave like the very giants it once challenged. For MacLean, the test has always been whether it can grow without losing the underground intelligence that built its name. That question became more emotional. After the passing of Don MacLean in 2024, founder gives a company more than a name. A founder can give it a way of seeing, a set of instincts, a sense of what matters and what should never be compromised. But when the founder is gone, the company faces a different kind of test. What was once carried by one person has to be carried by culture. It has to live in managers, engineers, welders, service technicians, designers, sales teams, and the next generation of leadership. It has to survive not as a tribute but as a practice. A company cannot live forever on biography. It has to turn biography into discipline. For MacLean Engineering, that discipline is visible in the continued focus on underground mining problems, safer equipment, more productive machines, cleaner power systems, stronger service networks, and designs shaped by the real conditions below the surface. You can picture the factory floor, a steel frame being welded, a massive tire waiting beside a chassis, hydraulic components arranged for assembly, a cab built for visibility and protection, a scissor mechanism rising in a test bay, a battery electric unit being prepared for a mine where diesel exhaust is no longer treated as an unavoidable cost of doing business. These are not relics, they are working tools, and that is what separates the MacLean story from many industrial rise and fall narratives. This is not the story of a famous factory fading into memory. It is the story of a manufacturer that survived by refusing to become nostalgic about its own success. The mine changed. MacLean changed with it. Manual exposure in ground support demanded better mechanization. Diesel mobility created new ventilation and air quality problems. Global mining customers demanded service beyond Canada. Electrification opened a new front in underground equipment design. In many industrial stories, the factory disappears because the world changes faster than the company. In this story, the company remains relevant because it treated change as part of the work. That does not mean the future is secure. Mining is cyclical. Commodity prices rise and fall. Capital spending can tighten. Customers can delay investment. Battery electric adoption can face infrastructure, cost and reliability questions. Larger competitors can move aggressively. New technologies may shift the industry again toward automation, robotics, remote operation, and systems that are only beginning to mature. MacLean's next challenge is not to protect the past, it is to keep earning its place. The method is the same one that shaped the beginning. Stay close to the mine, stay close to the worker, and stay close to the real operating problem. That is the lesson beneath the machines. Industrial greatness is often misunderstood. It is not always found in the largest smokestack, the biggest payroll, or the most famous brand. Sometimes it is found in a machine that solves a dangerous task so effectively that the improvement becomes ordinary, a bolter that keeps a worker farther from unsupported ground, a utility vehicle that keeps a remote operation moving. Battery electric machine that reduces heat and exhaust. Underground, a service technician who understands that downtime in a mine is not an inconvenience, but a crisis. The world notices mining when it produces gold, copper, nickel, iron ore, or the critical minerals needed for modern technology. But behind every ton moved is another industrial world. The manufacturers, tradespeople, engineers, and service teams whose names rarely reach the public. MacLean Engineering is one of those names. Its story matters because it reminds us that industrial power is not only found in the final product. It is found in the machines that make production possible. It is found in the workers who build those machines. It is found in towns that keep manufacturing knowledge alive. And it is found in the willingness to solve hard, unglamorous problems for people working in hard, unglamorous places. A mine is a hard place to pretend. Underground, weak ideas fail quickly. Heat builds, dust enters everything, steel bends, visibility narrows. Production pressure does not pause. A machine either earns its place or it is replaced. For more than half a century, MacLean Engineering has earned its place by building for that reality. It began with a mining engineer's understanding of risk. It grew through machines that made underground work safer and more productive. It adapted as mines moved toward cleaner and more electrified operations. And it carried a Canadian manufacturing name into a global industry where size alone was never enough. In the end, MacLean's story is not about a factory that vanished. It is about a factory that understood why so many others do. They drift away from the problem. They lose contact with the worker. They mistake scale for intelligence. They keep building for the world that made them successful. Even after that world has changed, MacLean Engineering's suggests another path. Listen to the ground, listen to the machine, listen to the people who work where the sunlight cannot reach, then build what they need next. And if stories like this about the machines, factories, and forgotten industries that shaped the modern world are the kind of stories you want to see more of, make sure to subscribe to the channel.